The world holds its breath. A colossal rocket stands silhouetted against the blazing dawn, its hull gleaming with promise. This is the moment, humanity's bold leap into the cosmic unknown. Metal and fire tower skyward, bathed in golden light. The countdown echoes, each second a drumbeat of anticipation. This is the pinnacle of human ingenuity, a monument to our relentless curiosity. This is not just a machine, it's a vessel for our dreams. Every bolt, every circuit, every line of code is a testament to our desire to break free from gravity and touch the stars. Centuries of wonder and ambition have led to this instant. From the first fragile flights to this thunderous ascent, we have always looked up, hungry to know what lies beyond. Inside the capsule, pioneers grip their seats, faces lit by flickering control panels, eyes wide with hope and fear. They are the vanguard, carrying the torch of humanity into the stars. The countdown thunders, 10, 9, 8, each number a heartbeat, each breath held. In mission control, eyes are locked on screens, nerves stretched to the breaking point. Everything must go perfectly. We leave Earth's cradle, breaking free from the only world we've ever known. The horizon falls away as we surge into the unknown. Not for a neighboring planet, but for another star. This journey will stretch the limits of time and distance, fueled by the unstoppable spirit of discovery. Engines roar to life, a symphony of thunder and flame. The ground shakes as power is unleashed. The ship rises, defying gravity's grip. Tremors ripple through the earth as we are hurled skyward, propelled by raw, unstoppable energy. Astronauts are pressed into their seats, faces contorted by G-forces as the rocket tears through the sky toward the stars. Earth shrinks below, a fragile blue marble suspended in the void. The enormity of what we leave behind is breathtaking. The ascent smooths. Booster stages fall away, cast off like old skin, as the ship surges forward, lighter, faster, unstoppable. The sky fades to black, scattered with distant suns. Before them the endless cosmos unfolds, a breathtaking panorama of possibility. Weightlessness takes hold, the crew floats, laughter and awe mingling in the silence, a surreal, liberating dance among the stars. No longer bound to Earth, they are true voyagers, gazing out at infinity, hearts pounding with wonder. The journey to Proxima Centauri begins, a voyage that will span decades, perhaps generations. The adventure is only just beginning. Across a vast ocean of emptiness, the only sounds are the hum of the ship and the beating of human hearts, undaunted, unbroken. This is more than technology. It's a triumph of imagination and perseverance, a testament to what we can achieve together. We refuse to be confined. We reach, we explore, we push the boundaries of the possible, because that is who we are. The sun shrinks behind us, just one star among countless others, a distant beacon, fading into the tapestry of the cosmos. Ahead a faint red dot beckons, Proxima Centauri, our new destination, promising new worlds and new beginnings. The adventure of lifetimes has begun, a journey into the unknown that will forever change who we are and how we see our place in the universe. Why Proxima Centauri? What makes this seemingly unremarkable red dwarf star such a compelling destination for interstellar exploration? Because it's our closest stellar neighbor. In the vast cosmic ocean, proximity is paramount. It represents the shortest, most accessible path to another star system, just 4.24 light-years away. While that distance is still immense, trillions of miles, it's a mere stone's throw on a galactic scale. It makes interstellar travel, while still incredibly challenging, at least conceivable within the realm of future technological possibilities. In a galaxy of hundreds of billions of stars, each a potential sun to countless planets, proximity matters. It drastically reduces the time, energy, and resources required for interstellar travel, making Proxima Centauri the most practical initial target. Proxima is the logical first step for interstellar travel, a stepping stone into the unknown, a chance to test our technologies and expand our understanding of the universe beyond our solar system. Any other star would be far more distant, requiring exponentially greater resources and posing significantly greater technological hurdles. Proxima Centauri offers a balance of accessibility and scientific potential. It's part of the Alpha Centauri system, a complex and fascinating stellar neighborhood. A trio of stars, Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, gravitationally bound and orbiting a common center of mass, each with unique potential, offering a diverse range of environments and scientific opportunities for exploration. Alpha Centauri A and B are sun-like stars, while Proxima Centauri is a red dwarf. A mission here means exploring not just one but an entire stellar system, but 3 stars and their planets, potentially uncovering a wealth of information about stellar formation, planetary evolution, and the possibility of life beyond Earth. The real excitement? The tantalizing possibility of finding a habitable world. In 2016, astronomers discovered a planet orbiting Proxima Centauri. Proxima b, a planet that has captured the imagination of scientists and space enthusiasts alike. It resides in the habitable zone, also known as the Goldilocks zone. This is the region where liquid water, a crucial ingredient for life as we know it, and possibly life, could exist. While Proxima b presents challenges, such as potential tidal locking and increased stellar flare activity, the possibility of liquid water remains a compelling reason for further investigation. The chance to find a biosphere so close to home, to potentially discover life beyond Earth within our stellar neighborhood, transforms this journey into one of profound discovery, a quest to answer one of humanity's most fundamental questions. Proxima Centauri is our stepping stone to the galaxy, a beacon of hope in the vast cosmic darkness. It's a tangible, achievable target, a destination that inspires innovation and pushes the boundaries of human ingenuity. For humanity's first leap beyond the solar system, a bold endeavor that will redefine our place in the universe. The journey isn't just exploration. It's a quest for knowledge, a drive to understand the cosmos and our place within it. It's the pursuit of the greatest scientific question, a question that has haunted humanity for centuries. Are we alone? Is there life beyond Earth? Proxima Centauri offers us the best chance to find out. Proxima Centauri is just over 4 light-years away, about 40 trillion kilometers. This dwarfs any journey humanity has ever attempted. For years, the crew would see only the unchanging blackness of space, the sun shrinking to a distant star. Familiar constellations would warp, and the psychological toll of isolation would be immense. Communication with Earth would take years. The crew must be entirely self-sufficient. As they near their destination, the Alpha Centauri system resolves into 3 stars with Proxima a dim red disk. They would be the first to witness an alien sun up close. The end of their journey would be marked by the dawn of a new star and the anticipation of discovery. The vast gulf between stars presents an almost unimaginable challenge. Crossing 40 trillion kilometers, the distance to even our nearest stellar neighbors, requires more than just conventional rockets. We need revolutionary propulsion systems, technologies that can redefine the limits of speed and endurance in the cosmos. The sheer scale of interstellar distances demands innovation. Fusion rockets, harnessing the power of stars by fusing light atomic nuclei, offer a tantalizing possibility. This process could generate immense thrust, far beyond chemical rockets, and potentially reach a significant fraction of light speed, offering a viable path to nearby stars within a human lifetime. Another promising avenue lies in laser sails, vast, ultra-thin sheets of reflective material designed to be pushed by powerful, precisely aimed Earth-based lasers. This method could accelerate tiny probes, unburdened by the weight of fuel, to speeds approaching 20% of the speed of light. At that pace, a journey to Proxima Centauri, our closest stellar neighbor, becomes a reality in just over 20 years. A timescale that brings interstellar exploration within reach. But such incredible speed brings inherent danger. Even a seemingly insignificant dust grain, impacting at these velocities, could release energy equivalent to a bomb, potentially destroying a ship. Therefore, powerful shielding, capable of deflecting or vaporizing such threats, and completely self-sustaining life support systems are absolutely essential for the long voyage. The ship must be a self-contained world, capable of recycling everything. Air, purifying and replenishing the atmosphere, water, reclaiming and purifying every drop, and food, cultivating sustenance from within. The spacecraft effectively becoming a closed ecosystem, a miniature biosphere sustaining its inhabitants for decades, and slowing down upon arrival is just as hard, if not harder, than speeding up in the first place. Fusion rockets, if employed for deceleration, might offer a solution, but would require carrying massive fuel reserves for the entire journey, significantly increasing the initial launch mass. Laser sails face the significant challenge of braking without a destination laser array to provide the necessary counterforce. Therefore, creative solutions, like deploying magnetic parachutes to interact with the interstellar medium, or utilizing stellar winds for braking, are desperately needed to solve this final hurdle. Solving these immense technological problems is the key to unlocking interstellar travel and finally reaching the stars. Life aboard an interstellar ship is a test of endurance and adaptability. The crew must be scientists, engineers, and farmers, maintaining the ship and growing food in hydroponic farms. Isolation is profound. Earth becomes a distant memory. The ship's design must support mental health. Communal areas, virtual reality, and recreation are vital. Social bonds and shared purpose are the glue of survival. On a generation ship, children and grandchildren may be born and die before arrival. Earth becomes legend. This raises deep questions. How does a society evolve in isolation? How is the mission's purpose preserved? Alternatively, suspended animation could let the original crew sleep through most of the journey, aging only a few years. They'd awaken at Proxima Centauri, ready to begin anew. Whether awake or asleep, the crew carries humanity's hopes across the stars. Arrival at Proxima Centauri is a transcendent moment. The red dwarf star dominates the view, casting eerie crimson light through the ship. The crew becomes the first humans to bask in the glow of another sun. Exploration begins, mapping the system, deploying probes, and studying Alpha Centauri A and B. The focus quickly turns to Proxima B. Telescopes reveal its clouds, oceans, or continents. The planet's light is strange, its landscapes alien, shaped by a red sun and violent stellar flares. The first question, does Proxima B have an atmosphere and could it support life? The starship becomes a permanent outpost, launching robotic landers to the surface. Humanity's first interstellar settlers begin their work. Their discoveries will forever change our understanding of the universe. Proxima B, slightly more massive than Earth, orbits close to its red dwarf, completing a year in just 11 days. It sits in the habitable zone, but conditions are extreme, likely tidally locked, with one side scorched and the other frozen. The Twilight Terminator zone may be mild enough for liquid water. Life here would be radically different, perhaps underground or deep in oceans, shielded from radiation. Photosynthetic organisms might be black or purple, adapted to the red-shifted light. Robotic probes would search for biosignatures, organic molecules, atmospheric gases, or even microbes. Finding any sign of life would be the most profound discovery in human history. It would prove we are not alone. Life would be a cosmic phenomenon, not just an earthly fluke. The search for life on Proxima B is the ultimate goal of our journey. Reaching Proxima Centauri would transform humanity's self-image. We would no longer be confined to one planet but become an interstellar species. This achievement would foster unity and a sense of shared destiny. Our world would seem both smaller and more precious. Scientific discoveries would reshape our understanding of life and the cosmos. If we find life, it sparks a new scientific revolution. If not, it highlights Earth's rarity. The data gathered would fuel progress for centuries. Ultimately, this journey is about the human spirit, our drive to explore and hope for the future. It marks the beginning of our adult life among the stars. The journey to Proxima Centauri is just the beginning. It's the first chapter in humanity's expansion into the galaxy. Each new mission builds on the last, pushing us further into the unknown. Imagine a future with settlements around many stars, each with unique cultures and challenges. This diaspora ensures our survival and sparks endless innovation. Every star is a destination, every world a new possibility. The journey starts with curiosity, with you, looking up at the night sky. Our sense of wonder drives us to explore, to dream, to reach. The universe is our inheritance and the frontier is endless. The first step to Proxima Centauri leads to a future grander than we can imagine.